Hello, good people. Today we're going to try something a little different. We're going to create dynamic 3D art. That's not different. The part that's different is we're going to do it backwards. We're going to start here at this completed project, like so. Strip away all of the components one by one and end up with just the basic template. Actually, an empty scene. I think it'll be fun. Let's give it a try. The first thing to strip out of this scene is the post-processing effects. In this case, it's this bokeh pass included in the Three.js extras, the add-ons. So I'm going to pull that out, and I won't need this render pass or the effects composer anymore because that's the only one I'm using, the only effect I'm using. So I just pulled out the imports, and let's pull out this post-processing here. Now if I save it, it's going to explode because it's trying to use this composer in the animate method. So we'll replace that with renderer, which we had already defined. And now we have our scene without post-processing. Slightly less good, I'd say. Still really cool. The next thing I want to do is to strip out the cool materials. Let's just simplify the materials we're using. So the first material I'm going to strip out is that toon material. I'm going to replace it with just a standard material. Each one of these spheres, you'll see it has like a three-tiered shading, you know, a dark, medium, and a light. And you can see it kind of rotating around because I'm rotating sunlight, this directional light around. Here in the thing group update method, where it doesn't belong, I'm rotating the sunlight position. I should probably refactor that so it's not part of the thing group another time. Great, so let's pull out that toon material. Here I'm defining it, and it's mag filter and min filter. Bye bye. And here the toon mat, we'll just call this Lambert mat now, because it's just going to be a mesh standard material. And I don't need the gradient map or the wireframe business. Just the color, like that. And this Lambert mat, I'm randomly assigning a material based on this probability, which is just a call to a random number. I'm going to replace toon mat with Lambert mat. Save it, and now we just have a standard material instead. Slightly less cool. This will continue to get less and less cool as we go. Next thing I want to pull out is that glass material. So from now on, material will not use a probability. We'll just do that Lambert mat. Okay? All of the icosahedrons and spheres are now just the same material. Actually kind of looks cool. I think I need to drop down the brightness a bit. What do you think of that background? I'm creating the background with this simple script I created called get BG sphere. Let's have a look at that. Here's get BG sphere. I'm creating mesh basic material, but then coloring the vertices based on their position. And what that gives me is a sphere whose inside out sphere, whose half of the vertices are colored, and you get this gradient. And I can reduce the brightness of that gradient, like so. See how it's dimmer now? And that's kind of what I want. I could also change the hue as well. Great, so that's a little bit dimmer. Okay, the next thing I'm going to do is to strip out the color variation. I don't need this glass material anymore. And here's my palette for creating different colors. I'm choosing a random index and using that random index to assign a hex color. And now I'm going to get rid of this color declaration and just define this as white. Okay, so no more random colors. Now they're all the same color. Next thing I'm going to do is to remove the animation. It's pretty easy to do that. I could just comment out this update method here, and now they're all static. But let's remove the code that goes along with that as well. It's this update method where I kind of define the radius from the center and then move these guys using this cosine and sine function. I'll be honest with you, I don't really know how this radial animation stuff works, but I know I'm defining two random angles, theta and phi, and then calculating these x, y, and z positions based on those angles. It's all going away. Hang on, the update methods and these guys as well. I still need this initial calculation to get their position, but I don't need to animate them anymore. And I don't need this update method either. Although I like having the sunlight moving around. Let's just see what it looks like with just the sunlight. And I'll uncomment this. And now you just see the sunlight moving around. That's really cool. Again, it's time to get rid of all the animation though. Bye-bye. Bye-bye, animation. We could reduce the number of guys now. Yeah, okay. The next thing in our regression, our backwards development today, is to only have one object instead of many. I'm going to get rid of this little loop statement here. And just get rid of this function. I'm just going to make it flat scene.add mesh here. And if I format, wait, how do you format again? There. Good. Let's see what that looks like. Now I just have one object, and if I reload, it's a different object. I'm still getting random probability, so occasionally I'll get this icosahedron, but that's it. One object. Let's remove that randomness, so now we have the same object every time, which will just be the icosahedron, because I love icosahedrons. Get rid of this probability, get rid of the ball geometry. In fact, we don't need to place it randomly. We could just drop it in the middle now, because there's just one. So we'll get rid of this radial positioning code. And get rid of tau, we don't need that either. Oh, actually we do. No more random objects. They just sit in the middle and get randomly rotated. Let's get rid of the orbit controls. Bye-bye orbit controls. Remove the import statement and remove the declaration or instantiation, and then remove the controls as well, that update method there. So no more controls and one object. It's getting more boring. All right, we've pretty much removed everything. Let's just get rid of the lights. No, it's just a dark object in the middle. Let's get rid of the object, and we don't need this math anymore. And we don't need this thing group either. All that's left is the background and an animate method that does nothing. In fact, we could just do this. Since we're not animating, we just render. Get rid of the BG sphere. That's it. We built it in reverse. Okay, let's build it up again. The first thing we'll add is that BG sphere. But here it is, get BG sphere, const BG sphere equals get BG sphere, scene.add BG sphere. Next, I want to add back the orbit controls. Instantiate those, const controls equals new orbit controls, enable damping equals true, and ctrls dot update. Now they're not going to work because I don't have an animation method at the moment. Make sure this is refreshing. It is. Let's create that animation method. Function animate. And we need request animation frame. Format it. I'm doing Shift Command F to format that. Oh, I gotta call the animate method. Animate. Sorry. Now we get that nice camera moving action. Let's add a thing. Const icogeo equals a new icosahedron. Why would I make it that small? And const ico, let's call it Lambert. Matt. Lambert's the name of the computer scientist who first developed this shading model back in the 1970s. Forgot his first name. I think I wanted to say Jack Lambert, who was a linebacker for the Pittsburgh Steelers in the 70s, but it's somebody Lambert. And mesh is equal to that, and scene.add mesh. There we go. Let's add some lights. Always like to start with the hemisphere light. And let's just make it 1 intensity for now. Oh, I've got to add it to the scene. I'm sitting here waiting for GitHub Copilot to write my code for me, and it's not doing it. You know what? That's going to be too big, so I'm going to make it half that big. I'm probably going to make it smaller later. Let's also add a sunlight as well. I mean, a directional light. These all look good. Thanks, GitHub Copilot. It's 2 over on the x-axis and 2 up on the y-axis. By the way, I'm going to flex a little bit and rewrite this. Set, and then 2, 2, whoops, 0. Let's create a reusable method and create a bunch of things. To do that, let's wrap this function get thing like that. And instead of adding it to the scene, just return it. Okay? Then, when we're ready for it, we say let thing equal get thing, and then scene.add thing. Format the code. No change, right? But we can create a bunch of them. I want to randomize this position. I'll get to that in a second. Const num things is equal to, wow, 25. And then for let I equals 0 while I is less than num things, I plus equals 1. Wow, look at all this stuff. And there's 25 things all on top of each other. You can't tell. Let's modify our getThing method and add positioning. First thing I want to do is define a radius. Hang on, how do I explain this? Because I'm positioning these things radially, I'm not positioning them just randomly in a grid space, or sorry, in a cubic space, but rather in a spherical space. I need a radius. Now I calculate a couple of angles, theta and phi. I think these roughly correspond to like u and v. Let me go ahead and calculate x, y, and z first. I wish I could explain these. I just know they work. It's a handy formula. And then set the position. Save. And it explodes. Why does it explode? Because thing is not defined. Fair enough. There. Okay, now if I set the radius to be a constant 2, they'll all kind of populate a sphere. Let's just demonstrate that a little more clearly, making this stuff smaller and more of them. See how they kind of define a sphere? That's what this magic math does. Instead of having a consistent radius, I'm going to randomize the radius, so now they fill the sphere as well. See what I mean? Okay, and I'll make these slightly bigger. Great. Now I got a bunch of things. I want to randomly rotate them as well. I'm just going to set the rotation to these random values. Tau is defined, const tau, as math.pi times 2. That's that. To make this more legible, you could just break it up by line like this. I think it's a little more legible then. Great. Now there's this nice random rotation on each guy. What's next? Oh, let's randomize the objects themselves. Right now we have a bunch of icospheres. Let's add in some smooth regular spheres. Okay, let's add this probability variable. And thank you, GitHub Copilot. We're going to set the geometry for the mesh, to be either this icogeo or the icogeo or ball geo. And let's define ball geo. It's an icosahedron, also same size, but much greater detail. Yeah, like that. Okay. If I were to reduce this randomness, let's say if it's less than 1, it's an icosphere. Now we'll have far fewer icospheres. Duh, right? Okay, so moving on. Let's add some random colors. I'm going to do that, but with this line of code, where I'm defining just an array of hex values. This is a palette that I'm calling warm and cool. I pulled this off of coolers. What is it called? Coolers.co. I'm not going to go there right now. Check it out. You can just create palettes and use them. Or check out some of my other videos where I do this same thing. I'm just not going to do it now. I want to grab one of those values, a random one. To do that, I'm going to do it right above the Lambert material. Say const hex equals okay, what's this line of code doing? Grabbing a random number and multiplying it by the number of elements in this array. And then I'm just taking the whole number part of that. I'm getting rid of the fractional part, using that as an index to pull a value out. And now I could just say hex. It looks a little dark now. Let's pump up the hemisphere light a little bit. Yeah, and the sunlight too. It's a little better. Yeah. Quick note, the sunlight and the hemisphere light do not affect the background gradient in this case, since it's using a basic material, which does not take lights into account. Great. Let's animate these guys. First thing I want to do is define some variables we'll use in the animate method. A speed, a range, and an oscillation range. You could think of a range as the limits of this random range I'm defining on line 43. All right. Now let's add a function that we're calling update. Define a current radius, which is changing over time. Time is defined in this t variable. Calculate x, calculate y, and calculate z. That's it. There's the update method. Let's create a thing group to contain the things we want to animate so that we can just iterate over those. Thing group. I'm going to define the thing group right here. Const thing group equals a new 3.group scene.add thing group. That's it. Now I've added all of my new elements to that thing group, no longer adding them to the scene, but to the thing group, which is already a part of the scene. If I save it, it should just look the same. But now I can do this, thing group dot children dot for each. So every child of that guy will have this call made to it. I don't need this performance.now. In fact, I'm just going to pass t times 0.01. T is defined here. And, oh, it's moving really slowly. Let's move it a little bit faster. Oh, I think I'm reducing it in here as well. Hang on, where's my update method? Here. Oscillation speed. Yeah, see, I'm fractionalizing that already, so I don't need to do it here. I'm just going to pass it in like that. It's calculating that new position based on these variables that I've set here. Cool, right? A quick point of housekeeping. let's add this user data to make things cleaner. There. Okay, now let's add more materials. It's a mesh physical material. I think I'll just tweak these and show what they look like. And the thickness is kind of the amount of refraction you'll get. And then I want to add this. Hang on, this needs to go up above here. With this same probability variable, I'm going to pick a material now. It'll either be Lambert matte or glass matte. Save that. How cool is that? It's kind of the opposite of what I had before, so I'm going to switch it. For the material, I want it to be greater than. And now all of the icospheres are this beautiful mesh physical material with refractive properties. If I drop the thickness down to 1, I don't think it's going to refract at all. Oh, it refracts a little bit. But if I drop it to 0, then it doesn't refract. Yeah, they're just these little transparent, ghostly shapes. I liked it at 3. Take a look at what roughness does. It makes it kind of opaque. And that's not good. I bet a value of 0.5 might look more interesting. Yeah, so now it's kind of this frosted glass look. Love that look. I like it at 0 though. Transmission, they're going to be black. Or sorry, they just look like solid things now. But if I make it fully transmissive, then we see through them. Yay! Almost done. Let's replace that standard material with a MeshToonMaterial. Let's define the MeshToonMaterial, replacing this Lambert matte. I'm going to define the MeshToonMaterial outside of the getThing method because I don't need to load a texture every time I get a thing. I just need to do it one time. And here, I'll use it. Const toonmat equals a new MeshToonMaterial. The color is the hex. I'm using that gradient mat I defined right here. Gradient map, I mean. And wireframe is false. Who cares? Don't need that. Now let's replace references to Lambert matte with toonmat. Get rid of Lambert matte and save. Look at that. We got the toonMaterial now. I want to animate, just slowly rotate all of the things. Let's define an update method for the thing group. Thing group dot user data dot update is equal to function. And that's exactly right. I'm just going to gently rotate on the y-axis, update each child or children, update each children, and then also animate the sunlight. Now, instead of this thing group.children.forEach, which I'm now calling up above, I'll just say user data.update. See what happens. It's going a little bit too fast, but it's still cool. Oh, I think it's so cool. I'm just going to slow it down slightly. The last thing to do, oh, I love this. The last thing to do is to add the post-processing effects. We want to grab a bokeh pass. This is going to blur things out and create cool bokeh effects. Get this blurriness and you get these cool highlights as well. But to use this, we need to use an effects composer, and we also want to grab this render pass while we're at it. I'm going to drop the post-processing in right below my orbit controls declaration. First thing I'm going to do is grab that render pass. You could think of this just as a render that we're going to mix into the composer. Here's a bokeh pass. I like these settings. I don't know. Just play with them and see what works for you. Now, instantiate an effects composer, which uses the renderer. Then add the render pass and add the bokeh pass. Before this will work, if I save this, you're not going to see anything. I need to tell the renderer to use this composer instead of using the renderer. So let's do that in our animate method. Replace renderer with composer and hit save. Wow, what a big difference. To compensate for the difference, like we lost a lot of light, I think. Let's pump up this background sphere again so that gradient is starting to come back. I'm going to make it even higher. Yeah, like that. And we can turn up the intensity of our lights if we want. I'm going to make the hemisphere light just a little bit brighter. Oof, that looks good. And this is slightly brighter too for the sunlight. Wow. I think that's everything. Thanks so much for coming by. If you enjoyed this video, share it with your friends. Tell people about my channel. It really helps it grow. If you want to support my channel, you can do so over on Patreon. Yeah. Thanks so much for watching. I'll see you in the next one.